Hey everyone, welcome to another interesting session in the math class. In one of my previous videos, you might have seen how do you understand the concept of eigenvalues and eigenvectors, right? As you relate that to a particular matrix transformation, we understood what you mean by an eigenvalue and an eigenvector, right? We understood the concept. In today's video, what we're going to do is we're going to try to find out the eigenvalues and eigenvectors for one of our sample matrix transformations, right? We're going to see how we find out the eigenvalue and eigenvector for a matrix transformation, right? So without wasting further time, let's go to the whiteboard. All right, so we know that a particular vector V is an eigenvector of a matrix transformation A if you apply the matrix transformation to the vector V, the result is only an extension or compression of the vector, right? The direction remains the same. So this transformation, if it's applied to the vector, right, what happens is only the vector undergoes a change in the length of the vector, right? It stretches or reduces. Let's say the variable lambda, the Greek letter lambda denotes an amount of stretching or reducing, right? Suppose the vector stretches by, say, 10 times, then lambda equals 10, right? Suppose it, say, compresses by half. In that case, lambda is going to be equal to 0.5 because the vector becomes half of its original dimension, right? So that's what lambda is. So basically, AV equals lambda V. This basically represents an eigen transformation, right? Suppose you multiply this side by the identity matrix I. Both the sides should remain unchanged, right? Because I is just like an identity matrix. So AV equals lambda I V, all right? So now you bring this to the LHS. So this becomes AV minus lambda I V equals 0. All right. So now if you take V as a common factor, then A minus lambda I into V equals 0. All right. So this is the fundamental governing equation for finding out the eigen values and the eigenvectors. So suppose you have a matrix, like say, and there's just a small change here. You have to make a determinant of this. Okay. So determinant of A minus lambda I into V is basically 0. Okay. So you can just say determinant of A minus lambda I. You have to equate this to 0. This will give you the eigenvectors. So like suppose you have like a matrix A that equals the A, B, C, D, right? Then in that case, A minus lambda I is basically what? This minus lambda into 1, 0, 0, 1, which is basically A, B, C, D minus lambda 0, 0, lambda, right? So this effectively becomes A minus lambda, B, C, and D minus lambda, right? So this, the determinant of this should be equal to 0. So basically A minus lambda into D minus lambda minus BC equals 0. When you solve for this equation, right, you'll get two values of lambda because it's a quadratic equation, right? So the first value, lambda 1, is the value of the first eigenvalue, and lambda 2 is the second eigenvalue. And then using this, you substitute these two value backs into this equation, right? And we'll see how we do it, right? Let's take an example, right? So the example we take is, let's take a new page now. Let's say A equals 4, 2, 1, 3. That's the matrix, all right? Now you have to find out the eigenvalues and eigenvectors for this matrix, okay? So let's divide this page into 2. So what's the governing equation here? A minus lambda I equals 0. Determinant of A minus lambda I equals 0, right? So as we saw earlier, basically we get this part like this. 4 minus lambda 1, 2, 3 minus lambda equal to 0. This determinant is 0, right? So now let's solve for this. 4 minus lambda into 3 minus 4 minus lambda into 3 minus lambda minus 2 equals 0. Basically multiply this into this and then subtract that from this into this, right? So this equals 0. So now we solve for this. 12 minus 4 lambda minus 3 lambda plus lambda square minus 2 equals 0. Okay? So we rearrange this. Lambda square minus 7 lambda plus 10 equals 0. Now we split 7 lambda into 2 such that lambda square minus 5 lambda minus 2 lambda plus 10 equals 0. We are solving a quadratic equation now. So lambda into lambda minus 5 minus 2 into lambda minus 5 equals 0. So basically, lambda minus 2 into lambda minus 5 equals 0. All right? So this means lambda equals 2 or 5. So basically, the first eigenvalue is 2 and second one is 5, right? So now using both of these, let's try to find out the eigenvectors. So let's say if lambda 1 equals 2, right? So let's substitute this into this equation now. So basically, let's say the eigenvector v equals x1, x2, right? Okay, now we're trying to find out the value of x1, x2 based on this equation. So determinant of 4 minus 2, because lambda 1 is 2, right? So 4 minus 2, 1, and 2, and 3 minus 2, right? Or not determinant, the matrix itself, right? Into x1, x2 equals 0, right? So solve for this. So this basically becomes 2, 1, 2, 1, right? Into x1, x2 equals 0, 0. This basically means, if you solve for the first one, 2x1 plus x2 equals 0. From here, you get 2x1 equals minus x2, right? So that's the first part here. So suppose like say x1 equals 1, then x2 equals minus 2, right? Clear? So the first eigenvector v1 is equal to 1 minus 2. Or it can also be minus 1 and 2, whichever way you see that, right? And now to find the second eigenvector, say lambda 2 equals this one, 5. All right, so substituting again in this part, you get 4 minus 5, 1, 2, and 3 minus 5 into x1, x2 equals 0, 0. All right, so if you solve for this, you get minus 1, 1, 2, and minus 2 into x1, x2 equals 0, 0. So if you say substitute this, solve for this one, you get minus x1 plus x2 equals 0. Basically, x1 equals x2. So here if x1 equals 1, then x2 also equals 1, right? The second eigenvector, v2, is basically 1, 1. Can also be like -1, -1, whatever you think it to be, right? So in this way, we found out the two eigenvectors, right? The first one is 1, -2. The second one is 1, 1. All right, so that's the method by which you find out the eigenvalues and eigenvectors for any matrix transformation. All right. So I hope you like this video. For more such videos, please subscribe to the channel and please comment on the uh, videos at the bottom if you want any content of your choice to be created, and I'll be happy to create content of your choice, right? Explain any topic to you. So I wish you good luck with your preparation, and until then, take care. See you in another video. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.